Okay, so that's the laptop, and we need to add a card, wireless card. So I turn it off by going into physical, and that's a LAN card which is already there. So I remove it, and then I add this WPC 300N card, which is wireless card. So it has that antenna, WPC 300N, and then turn it on. And you will see that as soon as it is turned on, because everything is on default, so it will have a connection to the wireless router. We can verify that by going into desktop and then going into PC wireless. Connect, and you see default it is getting 87% of the signals, and everything is on default mode. Network type is BGN, radio band is autos, there is no security. And we have already learned in our previous labs that how we can configure a security here, WEP, WPA2, and then we put a passphrase. So that's what which we already learned in our previous lab. In lab assessment, I might ask you that, okay, put a WPA2 security, okay, choose this protocol, and then use that passphrase. Okay, now if you go to the IP configuration laptop, you see that it has got an IP address via DHCP. This wireless router is configured to act as a DHCP server. So it is giving that IP address 192.168.0.100, and it has a default gateway of that 0.1. Now the topology, the basic configuration is already there now. This PC has an IP address. This PC0 and PC1, they don't have IP address, so we need to assign that. According to that topology, PC1 should have a 10.10 and PC2 has 20.10 IP address. So I'll change the name of that. I'm using _2 because it don't allow me to put PC1 here while PC1 is already name is given here. So 10.10. So I go to the configuration. So desktop IP address static 172.16.10.10. Mask is 255.0, and default gateway will be that IP address, which is one of router gig 00 interface, and it is 172.16.10.1. Yeah, that's it. Go to PC2 desktop IP address, IP configuration on desktop. It will have 20, so 172.16.20, sorry, 20.10. 20.10, yeah. 172.16.20.10. Mask is 255.255.255. This is also a common mistake. By default, it will take, because it's a class B network, it will give you a mask of 255.255.0.0. You have to change it to 255.255.255.0. Default gateway is the gig interface here, the IP address of that gig 00 interface, which is 172.16.20.1. So now the router PC basic configuration is already done. Each router, they can ping on the serial interfaces. This is okay. And they already know about these networks, directly connected networks. But routers, they don't have any idea about remote networks. If you're on R1, you see this R1, directly connected network is 172.16.10.0 and 192.168.12.0. But this router have no idea about that network, which is 172.16.20 and also 192.168.23 and also 30.0 network. We need to tell this router, okay? We need to tell this router that there are some networks on that side. And for that, we use static routing. So now I will show you how we configure it. So on the router 1, enable mode, show IP interface brief. First of all, we get the idea about the layer 3. Gig interface, up and up, good. Serial interface, 12.1, up and up. And if I give show IP route command, you see it only knows about 10.0 network and 12.0 network. That's the only known, this network and that network. This router don't have any information about that and that and that other 3 networks. So what we do, according to this lab, we're gonna create a default static route. Default static route on this router in this direction, away from this router. Default static route means catch everything. If that destination IP address is not here within your LAN, just send it towards R2. So how we do that? Conf terminal, global configuration mode, and then we use a command IP route. That's a command which we use for the static routing. And then 0.0.0 space 0.0.0.0 space. So it is catching everything. It is catching everything. Now after that we have 2 options. Either we can give a local exiting interface or we can give a next hop IP address. 2 things. Both options are available. And if you put question mark, it will tell you. You see? Gig interface. So in this lab, I will use local exiting interface, which is serial 0/0/0. Enter. Okay. There is what's wrong? Serial 0/0/0. Enter. Okay. So it is not taking S. All right. So R1, whatever it is receiving, it will send towards R2. Similarly, we will do the same on R3 as well. Whatever it will receive from this side, it will send towards R2. Default static route. Enable conf terminal IP route 0.0.0.0 space 0.0.0.0 space, and then serial 0. Over here the interface is serial 001. There is a message: default route without gateway, if not a point-to-point interface, may impact performance. But we are using point-to-point interface, so no problem for us. So that's the configuration which we have done. The default configuration. Default static route is configured on R1 and R3. Now for the reverse direction on R2, we will create 2 static routes. R2 needs to know about this network, okay, and also about that network. For R2, this is directly connected network, that is also directly connected, and that is also, but these 2 networks are unknown. So on R2 we will create static routes. Enable conf terminal The command is same, IP route, the starting command is same, but now I will give the network address, which is 172.16.10.0 network. 172.16.10.0. This is the destination network from here to here, and then the mask value, which is 255.255.255.0. And then after that, again, there are two options. Either we can use exiting interface, local, or next hop IP address. I prefer exiting interface because it's less prone to mistakes. While you are typing a IP address or next hop IP address, you need to find out that IP address. But serial interface is already in front of you because you know that. So I'll use serial here again. Serial 0/0/0, which is that interface. Okay, so I'm on R2. This is for that network. I need to also create a network for this network, which is 172.16.30.0 network. Again, IP route 172.16.30.0. In this command, I'm using network address. Okay, not the IP address. Network address 30.0 mask.0, and then again local exiting interface serial 001. Okay, so that is our routing, static routing. A default static route from R1 towards R2, which will catch everything. Whatever packet it will receive, it will send towards that direction. Similarly on R3 as well, default. But on R2, two static routes. One for 172.16.10.0, the other one for the 30.0 network. And we can verify. If you remember that show IP route command, which I gave it first, so I didn't give it first here, but anyhow, show IP route. Now you see 10.0 network, 30.0 network, and other three networks. So there are 1, 2, 3, 4, 5, 6 networks. So other three networks are directly connected: 20, 12, and 23 for R2. For R1, what happened? For R1, show IP route. So it has two two directly connected networks, 10.0, 12.0, and then we have a default static route. So it is shown here in the routing table of R1 with this SN static. Is it this one? So it's an indication of static route, default static route. Sorry. Now we should be able to ping everywhere. We start from the laptop. So whenever we are in a packet tracer, it's a limitation of packet tracer. We have to start from the wireless router when the wireless router and wireless PCs are there. So we start from here. So it should be able to ping first here, then here, then here, and then here, and then here. We will test it, okay? So let's go to the computer. Command prompt. First of all, I will check IP address of my own laptop. So IP config. So it has a 0.100. Okay, and the 0.1 is the IP address here on this interface. So I'll ping that one first. Ping 192.168.0.1. which is working. Good. Okay, so up to here is fine. Now I need to check whether from here I can ping this gig 00 interface, which is 30.1 IP address. Ping 172.16.30.1. Good. So first request timed out is actually taken by the ARP request. So it is working. So I'm getting from here to here, all okay. Now I will ping this, which is 192.168.23.1. So 192, which is the R2 serial interface, 192.168.23.1. Good. So I'm getting here. Now let's check if I can ping PC2, which is 172.16.20.10. Good. Now I'll check whether I can ping all the way to R1 serial interface, which is 192.168.12.1, this interface. Good. And finally, I will check that I can ping this PC1, which has IP address of 172.16.10.10. Good. So everything is working. So that is the full demonstration of our lab, in which what we have done, we have configured 3 routers, normal routers, and then wireless router WRT300N, and then we made a full network topology, and we have used our static routing, default static routing and simple static routing.